Boje. So, hello together. So I'm the first after the break, not after the lunch. Yes, I'm Franz Tonnerer. I'm Managing Director of MAGNA Plastic, MAGNA division in Austria. Especially comes out of the MAGNA COSMA area, of the sheet metal area of MAGNA. And it is a honor for me that I can hear a presentation to you, to show you something, and I will talk about requirements. Requirements comes out of the product development, and after that, or at the same time, what's on the requirements comes to the tool and die area, to the tool and die development process and lead process. So, I will do a short introduction of MAGNA COSMA, MAGNA and MAGNA COSMA, and then I will talk about these two requirements, what I had talked before. And one is the comes out of the automotive supply chain, and after this, what goes from these requirements directly to the tool manufacturers. So when I talk about MAGNA, MAGNA is one of the most diversified automotive supplier in the world. So we have all the engineering services, product systems, vehicle assembly is a part of our program. We have exteriors, interiors, vision systems, seating systems, electronics, powertrain system, especially four-wheel systems, body and chassis systems, that's my home base especially, then closures and also roof systems. So we in all the modules around the car, we found our home base. We are located in a global area. We was founded in Canada. So in summary, we have 119,000 people. We are working in 29 countries in the world. We have 313 manufacturing facilities and 88 service centers, means development centers, marketing centers, sales centers, also all over the world. And our sales last year was near to 31 billion of US dollar. This was the whole MAGNA. So in the part of this family is COSMA International. COSMA International works on sheet metal especially, and we work also on the complete life cycle capability on all the areas comes out of sheet metals. We started with design, develop, make prototypes, make tests and validation, production, and also all the engineering jobs, what we have to do on the product development process. The core of MAGNA COSMA's expertise is the complete life cycle management, from the concept phase of a vehicle through production, engineering and design, prototyping, testing and production of body and chassis programs. The COSMA facilities are also all over the world. We have 62 production facilities and 22 engineering, R&D and sales centers. We have also 8 tooling factories, and in summer we have 21,000 employees. The sales is around about $7 billion. So that's the words to Magna and Magna COSMA. And now I will go in the next thing, in the requirements in the automotive supply chain. The growing requirements in the product development process make it necessary that we has also adapt our business processes, and I think the whole business process in the supply chain we have to adapt. Means the requirements of the product development process in the automotive industry, I think we can talk about it's very high, and is also behind some movements. We have to look at product cycle time. We have to decrease it. We have to increase our flexibility. We have to grow on the complexity. The varieties are permanently grow. The development quality we have permanently to improve. The cost pressure is always high. The regulations, instructions are always we have to respect, to look at, and they were very high. We work on a global base. So also the innovation, the pressure of the innovation is permanently here, that we are on the competitive side, really have our right track. Then the development time has permanently to decrease, and we have to go with important speed in this development processes. And we have also permanently to look for international cooperation. We have to do cooperations with our competitors. We have to do it. That's a global work. We cannot really invest in all the regions where our customer is. So sometimes we have to work together. We have to found joint ventures or whatever. And what we see, and this is one I think of the important thing why we have to move, the individualization of the needs of our customer, of the user of car is growing very much and growing whole world. And we have also to look for our experts. We cannot always find our experts in the right places on where we have to start facilities. We have to start a new production, and we have to work on this pool of experts that we can really bring our performance. So in the end of the day, I think this is the key indicators, what we have always to look. We have also challenging in time targets. We have to increase of all of the quality requirements increase permanently. Then a cost pressure is coming up for all the suppliers in the chain, and also the globalization is one of the thing we have to look how we can handle this, how can we handle our investments on the right place. The reason for change within the requirements, there is a graphic you can see what's come out of in the past. We see that we have now platform strategy. We come more and more in this platform strategy and also in this modular strategy. So more and more variances of cars we have to design and to work on and to develop it. And this is always a good thing. We use more and more dies, more and more variances in dies. So when I look in the die and in the tool area. So why we have this situation? We have an increasing wish of individualization, what I talked before, a growing demand on product and diversity features, global requirements and also the environmental requirements and regulations we have to look at. So the automotive industry process map. I will show you here a graph. We see two main processes. One is the product development process, and from this product development process, we go into the product manufacturing process. We as a supplier to the automotive industry have to manage both of them. And you can see in these directions, we have the product development and we have also the product manufacturing development. And an important part of this is the tool development. And I will show here that we have also start with this area very early in this development phase. And this is one of our key, what we have to do in the next time. We as supplier to the automotive industry, and also I think you as tool and die area have to be involved in this early phase. That we really can make a tool development manufacturing in the same time when we do the product development process. And this is then, we find then, I think also the right time to do the market. We can speed up with this time. And then it's the next phase. We can handle then the product manufacturing processes. We have the right performance then there. And the right performance when we start with them. And that we have not potentials for furthermore continuous improvements, what we have to optimize then after the SOP. We have to find that we have to start on the SOP with the full performance outcome of these dies and tools. So that means that's then the time to the customer. So we have then to work also on the product development process and also on the product manufacturing process. Next thing we have to think about is what is the changes in the product development process. In the past, we have the serial product development process. We do it step by step. This was the past. I think it's really the past. We are now in the simultaneous engineering area. And when you look at this, I think we can save some time here in this area. We work overlapped. So, and we have also go in the next steps, we named it front loading. We have to bring more and more together, starting typically in the early phase. When we have the design, the concept design phase, we have also then very early to start with the tool development in this time. And I mean, then we can save time in this area. And I think we can go in, when we go in this front loading, we can early on consistent usage of digital technologies and methods is one of these tools and of database we can more use in the future than we do in this time, at this time. In the next chart, I will show you what's the typical thing what we have to think about. In the first area, we see we have hardware checks. We do hardware checks very late, too late. We go with simultaneous engineering, we go in the right direction, but we have to think about, we have to find the earliest phase here and this time that we do total digital mock-up, not on this physical mock-up, so really always do on data area, and that we can save this time And when we go to the coast picture, this is the coast curve. We in this area now, and we have to find this area. If we see, then we can really save much of coast. When we go the reason is that we go today in hardware sometimes, and we have to make changes in the steel, in the die. We have to do it only in the database, all the changements. And we have not only to think about forming processes, so we have to go deeper. We have to go in the whole process, in the whole system. So means we should go to the hardware check to the digital check. So now I will talk more about tool requirements. What are the future tool requirements, future or existing requirements, I think? When we talk about material, we have high-strength steel, always new steel, new materials comes up. The next point, lightweight, means all the thing at first aluminium, but also goes further and further in different hybrid materials. We have also to work on optimized all the blank sizes, the usage of material. And we see in the requirements permanently higher forming complexity. Comes out of new ideas and new design ideas, and we have to fulfill these wishes. And this is always why we have to work in a very early phase with the product development, that we can make changements in this early phase, and not after we say we cannot produce this, we cannot fulfill this process, and we get not out the right quality of the processes. So in the tool design, we have also to work. We have to shortening the lead time, and I hope we can shortening. We have to more go in this digital area, and to check more on the digital way. And then we have to think about optimize the whole stamping process, the whole system in this forming process. Means also the press force, the press sizes, the vibrations. So this is an important thing for us, that we can really be competitive on the market. Then there are also some press modifications. We see new transfer systems. We see new servo technologies. We talk about servo presses. We can speed up with servo presses. We can go on potentiometers and change all the ways and the speeds in these presses. That is free. It's years ago we talked about CNC machines, CNC milling machines. Now we can talk about CNC presses. I think that comes out of servo technology. And next step, we have also to work permanently on this surface coating, that we have the lifetime of the die, of the equipment of the die, have the right lifetime at the end of the day. And also a thing what we have to talk is the usage of the right die components corresponding to the lifetime volumes. We have so much different lifetime volumes today. When we talk about convertibles, we have over the whole lifetime 120,000 or lower. When we talk about special or the premium sport cars, we have only over lifetime 40 to 50,000 vehicles. So we have to create other dies when we talk about over the lifetime of 7 to 8 million cars, especially in platform parts, and when there are carryover parts in these platforms. So this is also to bring in, and should be also a cost factor. And the next one, ramp-up process. We think about we should go or set our goal, no tryout phase at the home press line. So our wish is when we get a die, when the die is delivered, we should run full speed. So this is our goal, what we have to work with you. I know we are not really have fulfilled this today. We have really to work hard on this way. And I think we have to hard with all the methods and dies and database what we have. And when I talk about database, we have also our surface database, and we have also to have our now database. When I think one of the components is typically spring back. Now you can work on spring backs also with programs that we can make our simulation on spring backs. Typically, this is one of these issues. So, as next, a higher quality of expectation. So, the process capability, no dimensional deviations. So, I think this ramp-up process is really a hard goal, but we have to look. We come up with them. That's why we have after SOP, we have a lot of potential for continuous improvement. And we should, this continuous improvement with all this experience, what we comes out of these continuous improvements should get in the development area, in the development thinking area. Yeah. So, and then comes for us, the important thing, the production process. We look that we have, after delivering the die, maximal strokes per hour, high equipment efficiency, means OEE, all the KPIs what we talk about, tool downtimes, important thing. Then the setup time, changeover time is always, we have so a lot of variances, and these variances comes up with setup, much of setups, what you have to do. So we have the one piece flow to fulfill, and so we have to, best way we have 0 setup time. So the die should easy to maintain, and also important for all the environment area, no lubrication. So we find the right coating system, that we have the surface coated in the right way, that we can run without lubrication. Yes, and so I will talk about how we can handle this, or how can we work on this. And I think we should talk about this product development process with this front loading, should be used as the right tool, and should make a copy and paste as new approach out of the product development to the tool development process. That we see on this picture once more, that we work really, that we start in the early phase and do it on this digital way, more on this digital way. Start us with the draw simulation in early phases, then supporting the product development and supporting also the material selection. In early phases of the product development, we can talk about also about the material. We cannot say we change it to the best for us, but we can talk about it, and we can give all our feedback there. And the other one is the kinematic simulation in the early phases about the whole process, the whole system process. Means the tool, the movement of the tool, the movement of the parts in the tool, then the special presses, typically link drive as existing system. Servo technology comes more and more up, and we can use this servo technology totally differently. I think we have to talk with the die developer, that they have the understanding what the server technology can bring for the die. And also all the peripheral equipment means transfer, coil feeder, blank loader, and so on. Also the whole system we should make, or can make a simulation. I have then a short movie. I hope we can start it. That you see this, for me, the understanding how this can work, and we have simulation software worked on that we can really check all the movements there, and all the crashes that can fixed in an early phase, and we can talk also about how much strokes we can run this die with this system. So, expectations out of these new methods should be the same picture what we have before, that we come up from these hardware checks, means prototypes. We should work without prototypes. Some of cars starts now. Renault starts with the new smart development for Daimler, and also I think for the Twingo, they start without prototypes. So this is a place so that we come on this point also from the development time, that we come here in this start area, and also from the coast side we found this point. So means reduction of hardware checks, then should be reduction of time and costs, prevention of waste, higher level of quality, more flexibility, better performance, and improve for us and for you the competitiveness. And for me, as a common understanding of the product development and the product manufacturing process will secure our successful future. When we think about China, Korean, I think we can work on this way, and we have the universities behind us and the right tools and databases that we really can work on this way. So this is my short presentation to you. Thanks for your attention, and I hope it's my view of this, and it's the view of a automotive serial supplier, and I hope we can talk about this.
Thank you very much.